While 3D printing or additive manufacturing was in the 80s mainly used for rapid prototyping, you will have seen that now, because the precision has increased, it can compete with industry processes. And during this pandemic, there's even more highlights to how important this technology is, because it allowed us to quickly create crucial protective equipment, like face shields. And the beauty of this technology is that everyone nowadays can do it from their home. And this is what I'm going to show you in this video. What is 3D printing? It means that you create a 3D object from a digital model. The first step is creating a digital model. You can do this either with specific software, or you can go to websites where you can already download the models that people have created for you. Now, in the second step, you put this in certain software, and this would allow you to create things such as support structure, which you might need in order to make sure that it doesn't collapse on itself. It allows you to control parameters such as the printing speed and the infill, so how porous is the material. So if we're working with typical filament printers, which are the most commonly used by hobby printers, then you have a specific code. So it will tell the nozzle in what direction it needs to go in order to create your object. And finally, you can paint your 3D model, just like what I've done with Olaf here. 3D printing is nowadays widely used in robotics, manufacturing, and the automotive industry. It's still used for prototyping, so it would allow you that if you want to develop a certain building, or for instance a particular shoe, you could print something on a smaller scale and see what it looks like. And they also use this in the James Bond movies, where rather than blowing up an entire car, they printed a small model, and then if you filmed it from a certain angle, it just looked like the car actually exploded. In my research lab, we also have several 3D printers. Now, we can use it for different things, such as for quickly prototyping and printing particular parts. And when we are working with sensors, we use this to make flow cells. So flow cells is where actually your sample would go in, and this is the place where you would actually measure the liquid or the sample that you're interested in. There are many of my colleagues that are working on different aspects, which could range as broadly from printing of prosthetics to sustainability, where we can make 3D printed resin from plastic waste, or reactors, where you can produce them on a bigger scale. There are different ways of how you can 3D print material. So you can use a particular resin, which means you need to photocure it and expose it to UV light. But unfortunately, if you would do this at home, it would be quite smelly because it has a very particular sweet smell. And this is the reactor that we use in my lab to do these things, and it has a very good precision. But if you would be working at home, the most common method is fused filament deposition. And what happens when you expose it to high temperatures, then it starts to melt, so you can mold it in the shape that you want, and you can give the nozzle instructions to move back and forward. So this material is what we call a thermoplast. So as soon as it cools down, it will solidify and you will get your 3D printed structure. But in recent years, other materials have come to the market, and that's given it a lot more flexibility. So think of, for instance, rubbery-like materials, such as ABS, which allows you to print flexible parts. You would be able to mix in conductive elements in the filament, so in order to make materials that are electrically conductive, or for instance, polyurethane. Well, imagine a future where everyone would have a 3D printer at home, and all you would need to do is you would just need to download the particular design that you want, and you can print what you want. That's how easy it would be. And it would be vary from printing to, for instance, pharmaceuticals, to support structures you want in your house, or biomaterials, and so on and so on. So hopefully with this video you can see what important role 3D printing plays in research, but also could play in everyday life. And if you want to see more about our videos, please subscribe to our channel or watch how we use these 3D printed flow cells in order to detect biological compounds, such as cardiac biomarkers.